No, I was just saying I don't have any questions.
Okay. So before we even get to chapter 1, which is basically our course, we are looking at some reviews. So it's a chapter called Review. And we want to go through 1 through 5. And let's start with, I'm going to share my screen. I do have the book open in the background. So I just want us to go to that. Where is my book? Here it is. And where are you guys? Too many windows open. Okay. So one thing that we have to refresh our memory on, in addition to graphing a piecewise defined function, is how to graph other equations, other functions. So I think for now it would be sufficient to look at problems 1 through 12. Can anyone tell us what type of equations are these from 1 through 12? Anyone, please? Can anyone tell us what type of equations are these 1 through 12?
Are they linear?
They are linear equations. Perfect. Can anyone please pick one? If not, I will pick. 1 through 12 on page 10, they are all linear equations. Since they are linear equations, what type of graphs will they have again? If they are linear equations, what type of graphs? Anyone, please? It's okay if you're wrong. We will discuss.
All real numbers?
You're talking about domain. Yes, I agree. If you're talking about the domain, yes. Domain of a linear function or linear equation is indeed negative infinity to infinity, all real numbers. I'm asking about how the graph will look like. How will a graph of a linear equation look like?
A straight line.
Absolutely. So it's a line. Line. Indeed. Perfect. So if you don't want to choose, I will choose, let's say 11. So this is 2x plus 5y equals 10. I will not contradict myself. When I mentioned a few minutes ago, I said every time I graph a function, I have to identify the domain and create a table of values and so on and so forth. Not for a simple linear equation or linear function. I'm not gonna. The domain, everybody knows that the domain of a linear function or polynomial for that matter is always all real numbers. And I will not create this table for the simplest possible equation or function that we have available, which is the linear one. But I would like to determine always, and we always try to find the x and y intercepts. Can anyone tell us how do we find the x-intercept and how do we find the y-intercept?
You set y equal to 0.
Yes, for the x-intercept, I have to set y equal to 0. Excellent. And here's what I do. Can anyone identify x?
It's 5.
Exactly, because y is 0, x is 5. Awesome. Which is the ordered pair that I will plot? Which ordered pair do I plot?
0, 5.
Careful.
Oh, 5, 0.
Indeed. X is always first, y is always second. Excellent. How do we find the y-intercept? Anyone, please?
Y equals 0. Or x equals 0.
Not or, but just x equals 0. Good. Can anyone tell us what is y?
2.
Exactly. Can anyone give us the ordered pair that we need to plot?
0, 2.
Excellent. So all I have to do is just plot 0, 2, 1, 2, plot 5, 0, 1, 2, 3, 4, 5, 0, connect and extend, and that's it. Always write the name of the function or equation that you just graphed. What is the name? The name is 2x plus 5y equals 10. I do not recommend solving for y. I do not recommend using the slope method. We always look for the x and y intercepts if they exist for all functions. The method with a slope, once you solve for y, etc., only works for this equation, for no other and no other. So we should always look for the x and y intercepts no matter what. Okay, I'm going to share again. The next item that I wanted to go over is something called compound interest. Compound interest. Anybody remembers the formula for the compound interest? Interest recalculated annually, quarterly, semi-annually, daily, hourly. Something like that. It's okay if you don't remember. Let's write it down. Any questions so far? Any questions here? Anyone?
Okay.
Perfect, thank you. So let's talk about compound interest. What does it mean? Well, the interest is recalculated. Annually means 1, weekly means 52 times a year, and so on and so forth. So the accumulated amount, I'm going to explain, I'm going to detail each and every one of them, of the letters that I'm going to use. P1 plus R over little n raised to n multiplied by t. So this is the compound interest formula. This is the accumulated value. This is value. Value. This is the principal. The money we deposit. This is the number of times the interest is compounded per year. Times per year. This is the annual interest rate. And this is the time in years. Time, years. Okay. So let me share. Let's take a look. Let's say purchases a 100,000 certificate of deposit from Newton Bank. Fine, at 2.8%. So far we have 100,000. So this is problem 31 on page 11. 100,000. We have 2.8%. And we have at the end of 1 year, if this is compounded such and such. So t equals 1 year. And we want part A, annually. Part B, semi. Part C, quarterly. D, daily. And E, hourly. Okay. So I already identified that T is 1 year. Can anyone tell us what this is? And can anyone tell us what this is based on what you see up here? What is this? What is this?
2.8 is the principal.
Yes. You mean the 100,000?
Yes.
Okay. And what is this?
Annual interest rate.
Very good. But remember, we have to change it into a decimal number. So 0.028 is the same with 2.8%. Now, I'm not going to, that's my preference. You have other options. But I am not going to recalculate the formula or use the formula 5 times. I'm going to do this. I am going to write the following. A equals 100,000, 1 plus 0.028 divided by x, because I do not have n in the calculator, and raised to x, because it's 1 times x. So this is the n, this is the n. Can anyone, we have to identify the n's now. So can anyone identify n for us here, n for us here, n here, n here, and n here? And then I'll show you how we proceed. N for part A. Marcus, what do you think?
Sorry, can you repeat the question?
Yes. What is n? What does n equal to in the annually situation?
How many years?
Interest compounded annually. How many times is that? What is n? What does n equal to?
Would it be 12?
Annually. Okay, let's say this is
One time.
exactly. Semi-annually.
Twice.
Good. Quarterly.
4.
Exactly. Daily, we know we consider 365. And hourly, of course, we don't know the calculation, but we have to multiply by 24 hours. 365 days multiplied by 24 hours in a day. Okay, so here's what I'm going to do. I'm going to enter this formula in the calculator. I'm going to share my screen. I'm going to go to the calculator. So in y equals, I will clear whatever I have. Do you want me to record this part?
If you could, yeah.
Okay, so we have 100,000. We open parentheses. We have 1 plus 0.028 divided by x. Close the parenthesis. Caret for the power. I like to put parentheses for the power. Not all calculators require it. This software does not, but I am too old at this point to change my habit on putting parentheses around the power. And actually, that doesn't have anything to do with my habit. It has to do with some calculators require it anyway. Good. Then make sure that with the second and table set, you have the independent variable in the ask mode. That's a mandatory situation because otherwise you will not be able to enter the numbers you want to enter. And then since I do have that, my independent variable is in the ask mode, I'll go to second and table, and I will just enter what I need. And what I need is 1, 2, 4, 365, and 365 multiplied by 24. Anything else that you do, it will require repeating the process several times, and it will take a long time for you to get those answers. So I already have the answers. What are they? First, accumulated value is 102,800. The second accumulated value, notice that I highlighted because the decimal digits may not appear. So the second one is 102, 819.60. The next one, 102, 829.54. The next one in line, 102, 839 and 46. And the last one, which is hourly, we have A is 102, 839.56. Again, I don't recommend you performing this operation and plugging in. You may make a mistake. You can type in something wrong. This is the best way, in my opinion. And that's how we deal with compound interest. So if you deposit 100,000 today at 2.8% for 1 year, and the interest, the bank says we are only compounding the interest annually, then you will get this at the end of 1 year. Twice a year, you'll get this, and so on and so forth. Any questions, please?